Page 27, theoretical versus experimental. Okay? Here's in a nutshell what we're going to discuss. Okay? What's the probability of drawing a red card, guys? The probability of drawing a red card on a deck of cards? 26 out of 52? That's half, isn't it? So 50%? 50-50, right? So if I were to draw a random card from this deck of cards, let's draw one. Let's do an experiment. It's a red card, right? Right? So right now, based on this experiment, I drew one card and I got a red card. So right now it's 100%. 100% chance, based on my experiment, that I'm drawing a red card. Let's shuffle this up. Do this again. I don't know. I'm just going to have to. I used to have an EA that actually worked at a casino, and she was really good at shuffling. Anyways, just a random card. Oh, it's black. So right now it's 50-50. Right out of two, we had one red, one black. Let's do it again. I'm gonna go grab a red one. Oh, there's red. So out of three pulls, how many reds did I have so far? 2. What is that as a percentage? Approximately 67%, right? 6 point, yeah. So wait a minute, isn't it 50%, Mr. Dirksen? But we just did our experiment and it's 67%. What's wrong there? Like, what's happening? This is the main problem. Me concluding that it's 67% is flawed. Okay, why is that? Because I've only drawn how many cards? 3 cards. If I did this for the rest of today's class, we just drew and drew and drew, and we would keep track of our total number of cards that we've drawn, and we collected the information of how many of those were red, I bet you it'd be close to 50%, right? Because the sample size has to be big enough so that your theoretical, because in theory we know it's 50%. But when we do an experiment, sometimes these don't jive. And the main reason is that they're not, that your sample size, the sample size is like how many times you've performed the experiment, is too small, okay? That is the bottom line here. And so you will see lots of examples in this section where the theoretical does not match your experimental, okay? Where what should happen doesn't match what actually happened. So here we go. Grab a highlighter or two. Experimental probability, EP. I will often talk about EP. Don't let this scare you. It just tells you that this is based on what actually happened. Okay? So this is it's based on trials, experiments, or number of surveys. So the experimental probability of A, which is the event happening, is favorable events, like how many of them are actually what you wanted, over what? Number of trials. So where would we use experimental probability? In sports, all the time. You cannot say that if the Jets play Tampa Bay, it's not 50-50, is it? It's you base it on what happened before. Like Jets are what, 11-1? They won 11 games and lost 1. And Tampa Bay was what? I don't know. They weren't as good. But obviously there was something we based it on experiment, right? Even the likelihood of someone having a certain blood type, right? It's not equally distributed. It's based on, right? There's way more of one blood type than another. Okay, so there's certain instances where you do want to use the experiment, the number of trials, what you've collected. Theoretical, on the other hand, right? Probability of the event occurring based on possible outcomes. Okay, so you base it on possible outcomes. And I will summarize it as follows, okay? That's why I leave the blank and the boxes down here. Experimental probability is based on what actually happened. If you can add this to your study sheet, like EP, experimental probability, is based on what actually happened. And theoretical probability tells us what should happen if sample is large. I have to say that. Okay, sometimes you'll be like, well, why do we do theoretical? It's wrong. No, it's not wrong. It's just that is actually what you expect to happen in the long run. Can I say that as well? What you expect to happen in the long run. Make sure you have those things added, because I will ask you, and the province will sometimes ask you. Tells us what should happen if the sample is large. So if I just asked this classroom right here, what's your favorite topping for pizza, right? And it's like almost everybody says pepperoni, and then I just say, well, sister likes pepperoni. Sister students just like pepperoni. Let's just order pepperoni. It's way too small of a sample. I should be asking a couple hundred students before I make a decision for 2,000 students, right? So that's the idea here. Here's another very important concept in general. When we perform experiments involving events where there is no bias, the experimental probability should be similar to the theoretical probability. Okay, I will use a different color here because I've used up my others. The experimental probability should be similar or equal to the theoretical probability. They may be different because there's a small sample space. Okay? Small sample space, sample size, it's all the same thing. Okay? Then experimental is not going to be equal to the theoretical. I think this is worth, on a very small, like you're not going to use up a whole lot of room in your study sheet, okay? But under probability, you should say that if the sample size is large enough, then what actually happened should match approximately. What are the squiggly lines? What happened there? Approximately. Approximately the same as theoretical. So the probability of drawing a red card is 50%. In theory, it should also be the case in real life when you perform enough experiments. Okay? All right. Another note. Very important. This is actually very, very important. When making a prediction, and you know both probabilities, right? And you know both probabilities, we use the theoretical to make a prediction what's going to happen in the long run. You do not use your experimental probability, okay? Prediction because you're comparing it to what's going to happen in the future, okay? All right, let's do some math now. Let's actually put this to the test, what we've just talked about. Let's see if you can know the difference. Let's go to 28. Look at that bag. I drew it with my mouse. Isn't that pretty? It's pretty hard to draw with your mouse. Anyways, a bag contains various letters as seen below. Alex draws a tile, records the results, then places the tile back in the bag. This process is repeated 8 times. Here are the results. Okay, so this is what actually happened. Oops. This is what actually happened. This is what actually happened, all right? So let's state the experimental probability of drawing the letter A. So we're going to go EP, experimental probability of drawing A. let me ask you, are you going to go to this bag here? Or are you going to resort to what actually happened? Well, this is experimental probability, so we have to base it on what actually happened. So how many times did he draw a tile? It says 8 times right here, but if you count 1, 2, 3, 4, 5, 6, 7, 8, 8 trials. Okay? And how many of those are A's? 3 A's. So that probability is 3 over 8. Let's turn that into a decimal. Okay, so that's the experimental probability. Now we're going to state the theoretical probability. Theoretical. What should happen? So we're going to go, to distinguish, we're going to go theoretical probability of drawing a letter A. So we base it on this, okay? We go to either the spinner, the dice, the cards, the deck of cards, whatever. We actually base it on this, and we count how many letters are in the bag. Total possible is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 letters. Okay, 10 letters. So that means that 10 is possible. Okay, 10. And how many A's do we have in here? 1, 2, 3. There's 3 A's in there. In bag. That is 3 over 10, which is 0.30, right, or 0.3. So in theory, we would expect 3 out of 10 tiles to be A's. But in actuality, based on experiment, it's 3 out of 8. So these are different. They're different, like what's happening. We always want to go by the theoretical technically. That's what's going to happen in the long run. So when the question asks, why is the experimental probability different, right? Why is the experimental different than the theoretical? And this is your magic bullet here, guys. You just say, this is due to the small number of trials or sample. Okay. How can Alex, right, change this? How can we make it that they're similar or almost the same? Alex should increase the number of trials or sample, okay, by drawing 100, 200 or more times, more tiles. Okay, so increase your sample space. The more times you perform the experiment, the closer they're gonna get, and sometimes even be exactly the same. Okay. Here's the prediction again. If Alex would draw 500 tiles, how many times would you expect to draw the letter A? Right? We're making a prediction. We're going way outside our 10, right, tiles. So we're going to use the theoretical probability. We're going to use the 3 over 10 theoretical probability. Okay, that's our theoretical. I'm going to highlight that later. We multiply that by 500. And that gets us exactly 150 times. I used green for experimental probability earlier, and I used orange for theoretical. So I'm just going to highlight the theoretical up here and just tell myself that's what I used here as well. Always use theoretical probability when making a prediction. If you know them both. Sometimes you'll only know experimental. Then you have no choice but to use the experimental. Okay? I hope you're listening to that part. Okay, I'm going to pause here. E and F. Can you answer E and F? It's still based on the exact same question. Let's see if you can figure out E and F based on what we've just done. So imagine I give you an AC right now. State the experimental probability of drawing the letter B, and then state the theoretical probability of drawing the letter B. Once you've done the probabilities, can you please state the odds as well for both of them? See if you can do that. It's good practice. All right. Just a minute or two, okay? All right. Let's see how you did. Experimental probability. So we got to go back to the actual experiment. There are 8 trials. That doesn't change. Right? That's what actually happened. How many B's are in there? Just one. 1 B. Okay? So it's 1 over 8, which is 0.125, which is 12.5%. You were okay there. That's fine. State the theoretical probability of drawing a letter B. So theoretical probability of drawing a B. I know I'm going back to my bag. I'm going back to my spinner, my deck of cards. Like I'm going back to what I used to perform the experiment, okay? And we know there's 10 in there. And how many B's are in that bag? I see 2 B's in there. Right? 10 letters. So this is 2 over 10. Hey, can we reduce this? I think it's okay to do that. 1 over 5. That's 0.2. That's 20%. So in theory, you're supposed to get, right, 2 out of 10, which is the equivalent of 20%. But in reality, you only get 12.5. That's what, based on your experiment, because it's too small. Let's come up with the odds here. How would you come up from probability to odds? Well, you go 1, and then you go 8 minus 1. So it'll be 1 to 7. Remember, these two numbers add up to your denominator. That's what you want. Next, odds. Right, we're going to figure that out. We're going to grab either this one or this one. It doesn't matter. If you grab this one, it's 2 to 10. Whoop, right? Make sure you take away the 2 that you already wrote down. So we're expecting 2 to 8 in theory. Okay, so the odds are different as well. And remember, I'm going to do this from now on. I'm going to take the 2, just carry it over. Just make sure you understand that that 2 gets subtracted from the total. Same here. That 1 gets subtracted from the total to get that. Okay. I'm going to stop talking and give you the rest of the class to just do a few. Please do a few just to wrap your head around it. I tried to put some images in there, deck of cards, things like that, so you can start thinking about this a little bit more. So basically, pages 2, I know that it's going to be a chunk of pages, 2 to 37, but obviously, if you do every other page, I'd be saying way to go. Okay? But don't just sit there and do nothing, right? That's not the way to go about it. That's not going to help you. So 29 to 37, I will post the key and get started, okay? And I can clarify anything that needs to be clarified. I'll post the